1. Kaolinite, Kandite group. The simplest arrangement characterizes the Kandite group of clays, most commonly represented by the mineral kaolinite, whose name is often used to refer to the Kandite group. Kaolinite is composed of an open-faced sandwich of one tetrahedral sheet and one octahedral sheet in each repeating layer, or a 1-1 arrangement. The layers are tightly bonded together, with only hydrogen cations between them, so their structure is H plus, O, T, H plus T, O, H plus, T, O, H plus, T, O. Unlike most other clays, there is no room for water, hydroxyls, or larger cations between the layers. Consequently, kaolinite clays are chemically and mineralogically simple compared to other clay minerals. Structure of kaolinite, the most common mineral in the Kandite group. Provenance and depositional setting of kaolinite clays. Clay minerals can be produced by the weathering of igneous, metamorphic, or sedimentary rocks. Although igneous rocks initially contain no clay minerals, the feldspars that largely constitute them decompose to clay minerals, especially when the topography is low and the climate warm and humid. Metamorphic rocks also contain feldspars and micas that decompose easily to clay. Weathering of pre-existing sedimentary rocks, especially other mudrocks, generates detritus rich in clay. The particular clay mineral produced is dictated by the extent of decomposition. Extensive alteration generates such clay minerals as kaolinite and gibbsite because interlayer cations such as Na, K, and Ca are completely leached away. Unfortunately, no trace of the original mica or feldspar type survives, so these degraded clay minerals provide no hint of source rock type. In the modern environment, certain clay minerals are associated with specific conditions. As we saw earlier, kaolinite is rich in aluminum but not in other cations. Consequently, it is abundant in areas of prolonged leaching, which concentrates aluminum, particularly if the parent material is also high in aluminum, for example, granites and rhyolites. Such leaching occurs most often in tropical soils with acid conditions and good drainage. The soils of the tropics are often so enriched in aluminum that they become a hard, crusty material known as laterite. Under some conditions, the aluminum concentration is so great that the soil can be mined for aluminum. This is known as bauxite ore. On the deep seafloor, where clays from the land eventually settle out, a predictable pattern can be seen. Kaolinites are most abundant in the tropical belts, especially adjacent to the mouths of major jungle rivers. Kaolinite and gibbsite are the major clay minerals in Mesozoic and Cenozoic rocks. Note that kaolinite is concentrated at the mouths of tropical rivers, because it is produced mainly in tropical soils. Kaolinite, 20%.